Olá, esta é a série áudio sobre IP e workflow no rádio, da trilha 7 Rádio do 7 Experience Academy. O tema deste módulo é a implementação do link estúdio-transmissor através de redes IP. O nosso convidado para discutir algumas dessas soluções é o Kevin Campbell, diretor de vendas da APT WorldCast Systems. Welcome, Kevin.
Thank you, Marco. Hello, and thank you for the invite today to talk about MPX Composite. My name is Kevin Campbell from WorldCast Systems, and I'm going to talk a little bit about MPX Composite transport, specifically for FM STL applications. Composite MPX, why? Well, basically, we've had composite MPX around for a number of years, mostly in the analog form and mostly over microwave. So 950 megahertz has been a very popular microwave transmission method for analog MPX. But laterally in the last number of years, we've had a standard AS192 for digital MPX. So this has allowed us to reposition some of the components in the FM broadcast chain. So if we look at what we had traditionally with an STL and the setup of the gear for FM broadcast, we had an STL link, which typically could have been an IP link or a microwave link or E1 or T1 in the past, where we delivered the baseband audio left and right, stereo for FM. And then we had the processing gear at the transmitter site, which produced a stereo image, which was then input to the FM transmitter for broadcast. So the audio was transmitted, and then the stereo image with the RDS, subcarriers, the pilot was generated at the transmitter site. And that's traditionally how it was done if you didn't have an analog STL. So what we can do now with the AS192, the digital composite, we can rearrange our broadcast chain a little bit, so we can take the sound processor back from the transmitter site, and we can generate the stereo image, the FM spectrum at the studio side. So that allows us to do a couple of things. One, we can generate the sonic signature, the audio flavor, if you like, of your FM, generate that at a central site and have that hit all of your transmitter and FM booster sites. So that means you've got less investment in expensive audio processing equipment, and of course you've got less maintenance. A lot of the FM transmitter sites around the world are hard to access. The less gear you have at these difficult to access sites, the better. So the more gear at the studio is definitely preferable. So less cost in terms of hardware, less cost in terms of maintenance, and you've got the ability to control completely your sonic signature. In some territories of the world where they're using managed services from telcos, they don't have that ability if the transmitter is located at the high site, at the transmitter site. So analog or digital, well, we can have a hybrid with our codec solutions because we have an analog IO, which is the traditional composite from many years ago, but we also then, of course, have the new digital MPX over AS or composite over AS as encaptured in the AS192 standard. So it's preferable to have the 100% digital path because you can eliminate any interferences that you can have in analog, and especially in a very RF dense site. It's preferable to have digital, but in a lot of territories of the world, we still have FM transmitters that don't have the AS192, the digital composite IO. So we are able to do digital composite at the studio side and have an analog composite or MPX output at the transmitter side. So you can still feed those legacy FM transmitters that don't have the AS192, the newer composite MPX input. So we can have a hybrid with the codec solution of APT WorldCast. As I say, it's absolutely preferable to have a full digital chain end to end. So one ASEBU cable can deliver the entire digital MPX, the entire FM spectrum into your transmitter. But if you don't, you can have the hybrid model with typically digital input from a newer audio processor at the studio side, and then a mixture of digital outputs where you have newer transmitters, but also analog outputs where you have older legacy transmitters that don't have the MPX composite input or interface. In terms of bandwidth requirements, obviously it's more requirement than a compressed audio signal, be that an MPEG, an ASC, Opus, or aptX, the lossless compression method that we've promoted in our codecs for many years. So with composite MPX, traditionally it's 24-bit or 16-bit. You're using, if you encode the entire MPX spectrum using a 24-bit word resolution, we're talking about 4.6 megabits, so it's quite heavy. If we go down to 16 bits, we're talking about 3 megabits. However, a lot of broadcasters will choose to only encode up to 64 kilobits of the FM spectrum, as there is no information, or at least for most broadcasters, there's no information carried in the subbands between 64 and 88 kilohertz. So basically, we're encoding the mono audio, left plus right, the stereo signal at 19 kilohertz pilot, and the RDS. After that, the signal is irrelevant because there's no information contained in most territories. Some places in the world there is information in the subband. The US, for example, use this for public broadcasting, for reading services for the blind. So of course, if you do need to encode that, your overhead is a little bit more at 3 megabits. So it's still quite heavy, either 2 megabits or 3 megabits, but we have a solution for that as well. So the other issue with composite, or consideration with composite MPX, is packet loss, and we have quite an undesirable artifact where if you have some packet loss, and of course IP audio we're talking about here, so your data stream, be it audio or MPX composite, is packetized, and if you lose some of those packets on the transmission link, in terms of MPX composite, that will give a very unwanted phenomenon, which is overmodulation. So within all of our MPX composite coding schemes, we include free of charge the overmodulation cancellation algorithm. So what this will do will filter out any overmodulation above and beyond 75 kilohertz, which is very important in some territories of the world, where the regulator will absolutely fine the broadcaster for overmodulating. So the overmodulation cancellation algorithm is a protection against packet loss and overmodulation due to that on all of our composite MPX coding schemes. Now, if we look at overmodulation cancellation, even with a 2% packet loss, we magnify up here, we can see that we've got quite an overshoot there, which is definitely going to bring the wrath of the regulator, depending on the market that you're in. So the OMC algorithm, the overmodulation cancellation, is really an insurance against any issue with packet loss when you're transporting an MPX composite using an IP codec, or using our IP codec, because it is our algorithm specific to our audio codec hardware. So bitrate is definitely a consideration. So we've developed a new algorithm which we call APT MPX. And APT MPX is allows you to scale back on the bandwidth that you require for the full, well, not the full, the 64 kilohertz limited 16-bit APT MPX composite. So with this non-destructive compression algorithm, we're able to further reduce the bandwidth requirement down to 860 kilobits. So where we were doing 2 megabits before on 16-bit with the bandwidth limited, we're now down to 860 kilobits. And this is the world's first non-destructive digital or analog and digital MPX composite compression scheme. So that has enabled us to use our existing SureStream technology, which has been around for many years, which has been used mostly to protect audio baseband links between studio and transmitter sites. But now, because of the reduced bandwidth requirements with APT-MPX down from 2 megabits on the linear scheme to just over 800 kilobits, we can protect the composite MPX delivery into your transmitter site over dual links using the SureStream technology, which is a redundant streaming technology. So we send basically the APT-MPX composite signal across 2 divergent links, and then we use an advanced resequencer at the far side to reconstitute any drop packets that have occurred on either link, thereby having a 100% lossless composite link at the transmitter site. And if we compare the APT-MPX algorithm with other compressed MPX signals, very simply, we're doing a non-destructive approach. So we take this entire FM spectrum up to 64 kilohertz in this case. If we talk about 860 kilobits, we can of course do up to 88 kilohertz, but we take that and we encode that in its entirety. So we don't deconstruct the signal. And remember, you've paid a lot of money for these high-end processors at the studio side. So we absolutely leave that sonic signature intact, and we then compress using our APT-MPX algorithm and uncompress at the far side. With the competing technologies, they're actually stripping the signal apart and then running the audio component through a psychoacoustic algorithm, thereby creating the compression in that way. So it's a completely different approach, and one that is absolutely not non-destructive, whereas the APT-MPX is completely non-destructive. So what you put in is what you get out at the far side, and your sonic signature is absolutely 100% intact. So in summary then, composite MPX. So why do it, and why look at WorldCast systems or APT codecs as the solution? So it will reduce dramatically the amount of hardware you have at the transmitter site. So typically where you needed to put an audio processor, an RDS encoder at every transmitter site to generate the stereo image for your FM transmitter, now you can do that at the studio and use multicast or multiple unicast technology over IP to distribute that signal from a single site. So where you needed 10 audio processors and RDS encoders to feed 10 FM transmitter sites, now you can do that with a single RDS encoder and a single audio processor at the studio side. So you've got a big cost reduction, not only in hardware, but also in maintenance, as you've got 1 or 2 equipment sitting at the studio as opposed to 20 equipments sitting across 10 transmitter sites. You've got flexibility with our solution, so we can mix up analog, the older composite MPX format, with the new digital AS192. We can also save now on transport costs with our new APT MPX. So we're doing much lower bit rates than the linear MPX composite, which goes from 4.6 megabits to 2 megabits. Now with APT MPX, this new algorithm, we're able to do around 860 kilobits, and we take care of any issues with packet loss, either by using our SureStream technology, which allows you to send the composite signal across 2 divergent links, and also with our overmodulation cancellation algorithm, which is included in all of the MPX composite coding schemes that we offer on all our codecs. So that concludes my presentation on composite MPX. for FM networks. My contact details will be posted here. If you require any further information, I'll be more than happy to provide it. And thank you once again for the invite to present today.
Thank you again for your presentation and participation. It was great.
It was a pleasure. Any questions or any clarifications, please let me know. And please make sure my email is there on the presentation as well.
Obrigado, Kevin, pela apresentação e participação na trilha 7 Rádio do 7 Experience Academy.